So, welcome back in the second lecture. In the first lecture, we have seen that given a property P concerning objects in a category, a dual property concerning objects can be associated. And similarly, given a property concerning a morphism, we can associate a dual property concerning the same morphism. And we have seen that they are non-equivalent in case of objects. So in this lecture we will see that the dual property are also in general non-equivalent for morphisms as well. So note is that Q opposite in C concerning the morphism F is not equivalent to QCF. So as an example, again we will take the category of sets. So take C equal to set, the category of all sets and functions, and take the statement QCF. So that the statement QCF was what? Given a function, suppose I take the same statement, given a function a to b f, there is a function g from b to a with G composition F is identity on A. So this function F has the property that I have the function in the reverse direction, such that when I take G composition F, it is identity on A. So this property QCP holds, the property Q set F holds if and only if the function F is injective, if and only if F is injective. Now if I take the opposite, the dual property Q opposite of set F, so the arrow would be changed and so does the composition. The direction of the arrow would be changed and so does the composition. So this would be given a function so now you have given a function f from b to a, given a function f from b to a, I have a function g from a to b. So the situation is like this. So b to a you have f, g from a to b, this is g, such that now I have f composition g. F composition g is identity on A. Now note that you must know from your previous knowledge that this condition for functions is true if and only if this condition for the function f is true if and only if f is surjective. So this is if and only if f is surjective. So therefore these statements are not equivalent, because you can have function on a set such that which is injective but not surjective. So the dual property is not equivalent to the given property concerning morphisms, as we have seen in case of objects. Now you can generalize this notion of having dual properties in more complex situation where you have a property for more than one objects and more than one morphisms. So this can be generalized to the situation where where P involves more than one objects A, B, C, so on, and morphisms so more than one morphisms can be involved, F, G, H, and so on. And you can give it the notation P, C, A, B, C, so on, F, G, H, so on. And if this property holds for all objects of the category and all morphisms of the category, then we say that the category has property P. And if it holds for all objects and all morphisms of C, then we say that the property PC holds, or alternatively we say that C has property P. C has property P. C has the property P. Okay. Now these were some of the basic things regarding the dual concept in categories. Now we come to the main theme of today's lectures. So we will actually formally discuss duality principle for categories, or principle of duality. So principle of duality for categories. So it states that whenever a property P holds for all categories, then the dual property P opposite holds for all categories. So whenever a property P holds for all categories, then the property P opposite holds for all categories. And the proof of this is simple. So note that, proof note that for all categories C opposite whole opposite is C itself. And from our previous discussions, now PC holds for all C if and only if PC opposite holds for all C. And if and only if, by our just in the last lecture we have seen this, if and only if P opposite holds, but in C opposite whole opposite, C opposite whole opposite for all C, but C opposite whole opposite is C. So if and only if P opposite C holds for all C. So this is the duality principle. Whenever a property P holds for all categories, then the property P opposite holds for all categories. So this is sort of buy one get one free situation for categories. Okay, so if you have a property which is true for all categories, then you always have the dual property which is also true for all categories. And this duality principle plays a very significant role in further topics to be discussed, because we will see that we have notions like monomorphisms in categories. So if a category has monomorphisms, then the opposite category will have epimorphisms, and so on. So we will see these things in our next lectures. So we stop this lecture here.